Okay. Yes, if you hear applause, it's because I finally got this to work. So, I would like to go through a process with you, and you should have a graphing calculator with you, and I'm pretty sure, does everybody have one? And I'm recording this so that people who are gone today can go through this process because it's a little involved, and you don't get it out of just looking at what is happening there. So, here's the scores, 25 student scores. We're defining the measures of spread for the entire class. So then if it's the entire class, is that the population or a sample? When it just states it that way, because it's not going to say which it is. The way they're saying it is the entire class. So it's considered a population. If you look down here, then use the last column of scores to find the measures of spreads, and then it comments that it's a sample. So one thing you might want to do is just give yourself a note that this will be the population that we're looking at. Range, no offense to range, it's all good, but range is less of interest to us, and it just doesn't tell us as much. Am I right in thinking the biggest number is 10, the littlest number is 2? What is the range? 8. 8 is the range. And so those I'll just show for this. Now we want the variance and the standard deviation. Variance is a lot of work. Standard deviation, though, is just the square root of the variance. So once we get the variance, we're all good to go. We're going to do this as a bunch of tables, and so I would suggest you write at the very least the headings of the tables in your notes so that you know what they are as we go through this, and we're going to kind of sequentially, we did this a little bit yesterday, but it was a smaller amount of numbers. So in list 1, you're going to put the scores. And list 1 means exactly that. We're going to count that as list 1, and I will be going between the computer and the smartboard because it's hard for me to manage the calculator over here. So list 1, there are your scores. Make sure that you can see them, and I'll show you what I'm going to do, but then I'm going to go away so that you can see that title. So if you remember how to do that, you push Stat and Edit. And if list 1 isn't there for you, somehow you've inadvertently deleted it, you can do one of two things. You can go second plus 712, which will just clear out everything and restore it the way it was. Or you can actually push this stat button, and there's this one called 5, setup editor, and press enter a couple times, and that will restore list 1 for you as well. So I just wanted to kind of go through that. I have the key history here. Every once in a while I'll clear that if I have to start over again. So again, we'll go to Stat, Edit, and then in list 1 you're going to enter the numbers that are here. And let's see, I'll go like this so you can see them. I'll freeze the board, and then I'm typing them in kind of as you are as well. So type those 25 numbers in list 1. Will you just raise your hand right now if you still need to see this list? Okay, and I could have made a mistake. Any of us could have made a mistake. That should become apparent after this very first calculation. So to find the variance, here they are in list one. I know I've entered 25 numbers. I don't necessarily know that whether I've made a mistake, but I know I've enter 25 numbers because it says list one is looking for the 26th number. So I know I've entered 25 numbers, and we'll kind of just go from there. So I have those scores in list one, and I think I went down the column, 7, 10, 10, da, da, da. That's all I'm going to put there. So the first thing I need for the variance is the mean, and so then I'm going to kind of find everything. So we're going to call that mu, and we're going to find the mean. We're going to make the calculator find the mean. It always calls the mean x bar, but that's okay. So I'm going to go to this, and I'm going to just tell you how to do that. Go second, quit. And then if you push stat, and then go, just kidding. If you go second stat, and you know, I don't use the calculator super a lot, so I sometimes forget where it is. If you go to second stat, you want to go to math. And there is mean, number 3. So I want the mean of list 1. And so I go mean of second 1 and enter. And just tell me, did we all get 7.44? Just, okay, because if you didn't get 7.44, it means either I entered something wrong or you did. And I'm gonna just round this or I'm gonna keep it at 7.44. If it's a long decimal, sometimes I will round it, but in this case, I can kind of do it the way that it is here. So mu is 7.44. The next thing I'm going to do is I'm going to find my scores, and list 1 is my scores. Those are my x values. So now I'm going to find the difference between my score and the mean. So this is going to be x minus mu. And it's going to be list 2 equals x minus mu. If we just calculated that mean, by the way, your calculator now knows mu is 7.44, or x bar it would call it, okay? So you can either use the symbol for mu, which is in the calculator, or you can use 7.44. For convenience, we'll just use 7.44. So go to stat and edit. And in that list 2, I want you to look at the calculator on the screen right now. Do you see where I'm ready to enter something? No. I'm going to go all the way up to L2, and then down here it should say L2 equals. And then I'm just going to type in list 1, because that's where I'm getting my x values, minus the mean. And so that's what I'll type, second 1 minus, and I could either use the mean or I'll just do 7.44. It wasn't that bad. If it was a long decimal, you want to use x bar, and then it'll use that actual value as we go. So I'm going to push or then enter, and it just calculates all those for me. And you don't necessarily have to do this, but I want you to think about this a second. And, you know, I have all these data values. If I lined them up from like low to high, the mean would be someplace in the middle. And all of these are some distance away from that. Do you know what I get when I add all the values in list 2 together? I should get 0. If you remember, I kind of commented on that yesterday. And now this isn't really part of our calculations, excuse me, but if I do that second stat again, and I go to the sum, and that's number 5 of list 2, it should be 0. Sometimes if I've used a decimal, it'll round and not quite be 0. But the reason I kind of keep pointing that out for you, and let me just go to this list so I'm ready. The reason I keep pointing that out to you is That's why we square and then square root at the end. We square it because that will make all of these positive. You can see some of them are negative, and that will make all of those positive, and then we'll have the kind of values that we want. So now I'm going to, that was that column, and then list 3 is going to be my x minus mu squared. So x minus mu squared. And so really that's, and I didn't say this, list 2 was really list 1 minus 7.44. And then this is list 3 is going to be list 2 squared. And so we'll just square list 2 to get that answer. So now back to the calculator, and I know this is taking me a little bit, but that's okay. So remember, go all the way to the top, and this is going to be list 2, second 2, and just squared, and I'll enter. And now those are all positive values. Now, I'm going to go back a second just to the formula. Let me kind of find that. So here's the formula. Just let's think about what we've done so far. We found mu, and then we took each value of x and subtracted mu, and squared it. So that's what we've done so far. Now we need to do this sum of that. And if you did pay attention, I already found a sum a minute ago. And so that's going to be our next list, which I can't write from sitting, although I'm getting good steps, so that's always a good thing. So list 4, oh, no, I don't really need a list for that, do I? Because what did I just say I wanted? I just want the sum of those, and so I don't have to do that as a list. I'm going to put that down here. I want the sum of list 3. I just want the sum of list 3. And I did go over how to do that, so if you're needing to kind of look for that, I'm going to go second. Oh, just a second. Did you notice I was in my list and then I went second stat? I really want to go second quit because I want it to be on that kind of home screen. So I'm going to go second stat. And do you know I can backtrack to math, right? You with me on that? Give me a head nod. Okay, just making sure. And I want the sum 5. The sum, you just have to help me. Is it list 3? Yes, okay. And so it's the sum of list 3, and that's 114.16. Do you agree with that? Okay, I just always like to make sure that we're in agreement. 114.16. Oh, just kidding. There we go. And so that's 114.16. And then kind of let's look at our equation. So that's the sum of all those. What do I have to do now? Divide by how many there are. And so the variance, notice this, I don't know that I commented on that before, but do you notice the variance doesn't have its own like letter or variable or symbol? It's just the square of the standard deviation. And so, but it is called the variance. So then to get our variance A and C. Our variance is the 114.16 divided by 25, which is called sigma squared. It's the square of that. And I don't know what that is, but I will tell you, or you can tell me. 4.5664. Okay, perfect. And that is 4.5664. And I'm confident that you can all find that on your calculator. So then the standard deviation is the square root of 4.5664. And so then what is that? 2 point something, right? Because 4 is 2 squared. 2 point, is it 1, 3? I'll go 2.1. is the standard deviation. Now, we can check ourselves using the calculator, and so I want to caution you here because it is super important that you understand what is behind this standard deviation. But, you know, I try not to hide things from you terribly a lot. And so if we go back to the home screen and we push stat, and I think we go over to calculate, and then see this one variable statistics, press enter there. Oh, and one variable statistics. Let's see, list one. Okay, I don't use these calculators that much, but okay, so then go down to calculate and boom. So let's just make sure that we know what the things are it's giving us, because in our previous work, we maybe didn't know what all these things stood for. So see how it lists X bar as 7.44? Because the calculator doesn't know if it's a population or a sample, correct? So there's our mean. And then this is just so the sum of all the x's. Did we use that at all? No. This is the sum of the x's squared. We're not using that in ours either. But now I want you to look at these things and notice this. Look, there's an SX and a sigma S. Or X, excuse me. And was that our standard deviation? 2.1. So if it's the population that, oh, you know what? Wait, I'm going to try something. Yes. Well, I'm just a little nervous, but okay. I don't know how to make it actually work. Oh, maybe never mind. Okay, that didn't work for me. Oh, but I can take a picture. So let me just have my little thing here. Did it go away? Okay, there we go. And here's one variable statistics. Does everybody see that little arrow? Oh, that was loud in my head. There you go. A little entertainment for this afternoon or whenever you happen to be looking at that. And so if that little arrow meant I can scroll down. And so I will take another picture of the bottom of this. And because I won't be going over all of these things repeatedly. So I want to just kind of have a good picture of everything. So now, one thing you have to be careful of here is, and now I have those on there. I think I'm done with that other thing. So I did take plastic sticks over there, so I'm running low on those, but that's okay. So the mean was there. This is the standard deviation that we just calculated. Now, remember at the beginning I asked you, is that the population or is it a sample, correct? Well, if it had been a sample, now listen carefully to this. If it had been a sample using those 25 pieces of data, not like this next question it's going to ask you, but if this were asking us to find the sample standard deviation, if you remember, the only difference between the standard deviation and the sample standard deviation is that at the variance here, instead of dividing by n, we divide by n minus 1. And so then in this one on the calculator now, it's giving us that sample standard deviation as well. And I'm not going to talk about the quartiles. I expect you just to kind of know about that. This also tells you how many numbers you had typed in. So in case you made a mistake, you know, that's there. Then the next numbers are the 5-number summary. And I'll just kind of draw a line there. And let's see, they're really right there is that 5-number summary. Just give me a head nod right now for those of you in the room. Do you remember how to do box plot or sometimes box and whisker plot or a box plot. Okay, we'll make a box plot of this data. So we'll come back to that in just a minute or two to make a box plot. Are you understanding how to do this with your calculator? Now, does the calculator actually give you the variance? No, it does not. So to get the variance when you're given the standard deviation, so to get the variance, you have to square this. So to get variance, you square the standard deviation. By the way, you'd like to square the standard deviation. How would you personally do that? I mean, am I going to take 2.1 and square it? I don't feel like that's a good enough number. Like, I'm not going to use that 2.1 and square it if I did this on my calculator and say, oh, it's, you know, whatever 2.1 squared is. I don't think that's good enough. So how would you do that then? Would you type in, you know, all these digits or a bunch of these digits and get it that way and then square that, like 2 point, so for the variance, would you take 2.136913662 and square that? Is that a way you could do that? Yeah. There is another way, and maybe I'll just kind of look over here. If I can't find it super fast, I'm not going to look for it. But get to know your graphing calculator a little better than maybe you have before. Do you see this key right here called vars? I'm going to clear the history. See this vars key? Vars stands for variables. Have you used that key ever? Okay, because I do in my classes, so you'll want to know about that key. So if you go to the vars key, and you know, I'm never sure where it is, probably in number 5, right? Does that sound like a good place to look? Statistics. So like, remember when I said, what was X bar? Really, it was mu for us, but it was 7.44. Suppose it had been a really long decimal. Instead of in that list, maybe list 2, where we went X, X minus, or list 1 minus 7.44, we could have just gone X minus, and we could have picked this X bar. So I can pick number 4, and I can square it. And is that the variance we had gotten? Okay, so the thing to be careful of is right now, my calculator, and if it worked the same for you, all of our calculators think, let me go second enter, answer, no, clear, second enter. All of our calculators, let me just delete that. Oh, I'm not always sure. There we go. All of our calculators right now have a set value for that standard deviation because it's calculated the standard deviation. So do you agree that even if you type another list of numbers in, unless you tell it to find the standard deviation of that list, then it's just going to use this standard deviation like forever until you tell it to make another standard deviation. Okay, so that's how to use the calculator. So now I want you to, let me kind of go back to our slides. Now, you decide how you're going to do this. So now you're just using that last column and either do the whole, you know, one variable statistics or whatever you want to do. And it was fine, the measures a sample of the last column. So that last column is 962,510. I'll just write it right here. 962,510. So take a minute. That's the sample you want. So find the range, the variance, and the standard deviation. And I'll just give you a moment or two to find that. Okay. I'm going to just go over these as you're kind of finishing up. You can just kind of check, and the work is all here as well. So the range is just 10 minus 2 or 8. And, you know, the range at the beginning was 8. This could have been a very different range for the variance. And now for the variance, or excuse me, the sample mean is 6.4. I don't think that, uh, oh, maybe it did work out to be exactly 6.4, but just be careful in case it doesn't. And so then if you're using, maybe you're just using the calculator to kind of find that. If you did, you found the standard deviation first, which is, oh, you know, actually, um, I see an error on our slide. Do you know what the error is? Anybody can find that? When I said, oh, when they found this, you get the standard deviation first. How did they label the standard deviation? With yeah, with sigma, but really it's the sample standard deviation, so it should have been S, and they gave it as S squared there. So that sample standard deviation, or the sample standard deviation, yes, is there, and then if you take that and square it, you should have gotten the variance, which is the sample standard deviation squared. And so just a little, you know, you decide at this point in your life, you can kind of decide what's going to work the best for you. Now, why do we care about standard deviation? In many, many areas, like one that comes to mind is as simple as the weight of every penny that exists. The weight of every penny that exists is not the same. Do you agree? I mean, they don't vary a lot, but they're not identical. But there's a mean at which they cluster, and then kind of, you know, there's some that are a little heavier or a little lighter, but as you go further out, there aren't a lot that are a lot lighter or a lot heavier. And so we get the standard normal distribution. And the standard normal distribution, I'm not always great at drawing it, but it's a bell-shaped curve. You've probably seen it, you know, in like a social studies class or things like that. Lots of places use that. The mean is right at the middle there, mu. And this is just talking about actual values. I don't care about that. Within one standard deviation of the mean, and so I'll use a little shading here because I like this visual picture a little better. Within one standard deviation of the mean is 68% of the data. And I think it says that, no, it doesn't maybe here. 68% of the data values, if it's a standard normal distribution, are within one standard deviation of the mean. Within one standard deviation means we can go one standard deviation that way or one standard deviation backwards or that other way. Then within two standard deviations of the mean, and I'm just estimating here, if I go out here at -2 or +2. And so this is within two standard deviations. So kind of this whole thing right there, within two standard deviations of the mean is 95% of the data. 95% of our data are within two standard deviations of the mean. And then within three standard deviations, and I'll use maybe this purple, and this is on a numerical scale, so those are equally spaced, even though mine aren't necessarily perfectly equally spaced. And within what did I say? Three standard deviations. Maybe I'll make that yellow just because. Within three standard deviations of the mean is 99.7% of the data. 99.7% of the data are within 3 standard deviations of the mean. And you know, if you are lucky enough to become a parent at some point in your life, when your baby is growing up, every wellness baby check, they compare the height and weight or length and weight of your baby to all the other babies, and that's what they're looking at to kind of help them decide if your child is progressing comparable to other children their age. And it's a good thing to kind of compare. And then, so then all the way out there, there are still values, but there are not, it's very much very unlikely. This next one, I'm just going to go through the answers with you because I'm going to say now that we can find the mean, the range, the standard deviation, and the median. Give me a head nod if you agree with all that. So we're just going to go over it. But I want you to look at these two groups. So just kind of glance at group 1 and glance at group 2. And those pieces of data. So metabolic rate is the rate at which the body consumes energy, measured in calories per 24 hours. During a study of diet and exercise, the metabolic rates of 2 groups of men were observed. Which group has a greater variation in metabolic rate? And so this part right here goes through that using the one variable statistics to find those things. The mean of this group is 1,603.9, this one 1,604. So their means their centers are very the same, correct? And so now their range, this one's 335, that one's 247. So these are more spread out. Do you agree? By the range. The standard deviation of these is 100.2. The standard deviation of these is 54.6. So when you just glanced at these lists, could you tell which one was more spread out than the other? No. Could you tell? I had a sense that their means were probably kind of close, right? Just because, they're all in the 15s, 14s, 16s, hundreds, and things like that. But this standard deviation of this group 2 is much smaller. So think about that bell-shaped curve. And so from that mean going 54 this way and 54 that way, that's 68% of the data. Whereas here, from that mean, which is about the same, I have to go 100 that way and 100 that way to get 68% of the data to fall within there. And then they also did the median. I'll just kind of get that out of there. And the median, or the middle, is 1591 and 1605. So that data is a little skewed as you look at it. So just kind of a little application problem, very common in a lot of looking at things. So now we're going to look at organizing data, frequency distributions, and so you want to know a little bit about this. Data can be organized in a table called a frequency distribution. Do you remember when we were calculating the one variable statistics? It maybe said frequency, didn't it? And that's because if I have 15 number 2s, instead of typing 2 15 times in my list, I could type 2 one time in a first list and then the number 15 in the second list. Does that make sense? Telling myself there are 15 of those 2s. So when it asked you for that frequency, you could have put in that list 2 was the frequency of each of those. So a frequency distribution shows how often the data values or group of data values called a class or interval appears in a data set. And the relative frequency of a class is the ratio of the data within the class to all of the classes. So that ratio, how much data is in our class or our little chunk of data over all of the data. And then a cumulative frequency, and I know here I can maybe slide this slide a little bit that way. There we go. My cumulative frequency is adding things as it goes, so that at the end I'll have everything accounted for. And so it is the cumulative frequency for a class is the sum of the frequency and all previous classes. So if I'm doing things cumulatively, I keep adding on all the previous stuff. If I'm just doing relative frequency, I'm just looking at that little chunk, this little chunk, the next little chunk. And then cumulative relative frequency is that ratio again. And so when we do it as a cumulative relative frequency, we get up to like 100%. As we go. So that's for a class is the ratio of the cumulative frequency of that class to all of the data. And I don't know if you've had this or if you have, it's been a while, but this class width then is a range of values for each class. And the lower class limit is the least value that can belong to the specific class limit. And then the upper class limit is the greatest value that can belong to a specific class. And then there's this little study tip about class value or boundaries. If the data values are non-integers, such as 19.2, the class boundaries are used to avoid gaps in data. So they should have an additional place value than the class limit and end in a 5. So for example, if that you had that 19.2, you would go like 9.5 to 19.5, 19.5 to 29.5 as it's looking at that. Okay, so here's our data, and we're going to make a distribution table that shows the frequency and the relative frequency of our data. And so we're actually just going to start with this, and we'll do this a little bit together. And we're going to look at our intervals and I'll just kind of show you those. So we'll go 10 to 19, 20 to 29, 30 to 39, 40 to 49, 50 to 59. And just looking at that data from the board, take a minute and I'll actually read them to you and you tally them as I go. Does that make sense? You ready? So you're just putting little tally marks. I don't know that I'll keep up with you because I'm just going to read them. So, oops, there we go. So the first one is 35, then 33. So you keep tallying. 16, 23, 16, 24, 14, 24, 16, 21, 32, 27, 35, 31, 27, 26, 27, 38, 38 again, 46, 39, 42, 20, 55, 20, 37, 52, 30, 49, 27, 35, 31, 34, 23, 34, 20, 48, 32, 24, 21, 29, 17. So how many digits were there between 10 and 19? 5. There should have been 5. And, you know, here's the tally marks. Between 20 and 29? 16. Between 30 and 39? 15. between 40 and 49, 4. And between 50 and 59, there should have been 2. So this is our frequency distribution. Here are our intervals, and here's our frequency. So this is just how many values there are. So our total is 42. Total is 42. And then to find the relative frequency, if the frequency of that is 5, how do I find the relative frequency? It's a ratio. 5 over what? 5 over 42. So 5 over 42 or 0.12. 16 over 42 or 0.38. You probably want to write it kind of both ways. 15 over 42 or 0.36. And 4 over 42 and 2 over 42. Now, we're also going to make the cumulative frequency in this same list. Cumulative frequency. And the cumulative frequency is the sum of the frequencies. So what is the total frequency there? 5, right? What's the cumulative frequency here? 16 plus 5, or 5 plus 16, which is what? 21. What's the cumulative frequency here? 5 plus 16 plus 15, or 36. This is 5 plus 16 plus 15 plus 4, or 40. This one is 5 plus 16 plus 15 plus 4, which is 42. Do you agree? And the last column we're going to make is the cumulative relative frequency. Cumulative relative frequency. And to get that, we're going to take 5 and divide by what? 42. But here we're going to take what divided by 42? 21 divided by 42. Then what? And then what's this one going to be? 42 divided by 42, which is what? 1, which is what is a percent? 100%. Okay. On the next page, I'll just kind of show you. You can then make histograms, and I'm sure you're all intelligent people. I'll let you kind of make those histograms. And this is the scores. This is in those classes, and this is what we just figured out. We just added those 2 columns. And then I want you to notice this. When you make, look what happens when you make the cumulative frequency. What's happening? It's growing, right? Because you're adding all those together as you go. Now, I didn't take time to look at quartiles, but do you kind of remember them? Remember we just did the 5-number summary? When you make this number line, you have to make it be equal intervals. The median goes at the middle, Q1, Q2, minimum, maximum. The box is in the middle here with a bar at the median. It goes to the minimum, it goes to the maximum, and the interquartile range is the difference between the upper and lower quartiles. The IQR is Q3 minus Q2, or Q1, my bad. And outliers are more than 1.5 times the interquartile range beyond the upper or lower quartiles. Tomorrow you have a quiz. Friday you have a test.